China has been building things at a pace that leaves the rest of the world scratching its head. Entire train lines appear in months. Towers rise from empty lots in weeks. Bridges stretch across open water, connecting places that used to be hours apart. Most people think this speed comes from having more workers or bigger budgets. But the real story is something else entirely. Behind nearly every major Chinese construction project in recent years sits a collection of machines so advanced that they are forcing engineers and governments around the globe to rethink what is possible. Right now, China has quietly developed 8 specific construction machines that are shocking everyone who sees them in action. These are not ideas on a drawing board or prototypes gathering dust in a warehouse. Every single one of them is already out working in the real world, handling projects that would have been impossible just a short time ago. We are talking about fleets of vehicles that pave highways with 0 human drivers, cranes that lower massive concrete tunnels onto the seabed with millimeter precision, walking robots that climb through disaster zones no human could safely enter, tunnel-boring machines that carve through the earth beneath your feet without you ever feeling a thing. And that is just the beginning. If you enjoy videos about cutting-edge engineering and technology, please take a quick second to hit the like button. These videos take a lot of effort to put together, and your support genuinely helps the channel grow. Also, subscribe so you do not miss the next one, because the world of construction technology is moving faster than most people realize. In this video, we are going through all 8 of these machines one by one. Some build things you use every day. Some work in places you will never see, deep underground or far out at sea. But every one of them is pushing past what anyone thought construction equipment could do. Let us start with the machines that lay the foundation for everything else. Machines that lay down the path. In 2025, a road construction project in China did something nobody had ever done before. A group of 10 self-driving construction vehicles rolled onto an empty stretch of land and began building a highway. There was nobody sitting in the driver's seat of any machine. Nobody operated controls by hand. The entire fleet moved together, guided by artificial intelligence and positioned by satellite signals accurate down to the centimeter. When they finished, 158 kilometers of smooth, fully paved highway stretched out behind them. The star of this fleet was a machine called the Sany SAP200C. It is an asphalt paver with a remarkable ability. In a single pass, it can lay down a strip of road 19 meters wide. To understand how wide that is, picture yourself standing in the center of a typical road. The Sany covers everything you see to your left, everything to your right, and then some, all in one continuous motion without pausing. The artificial intelligence controlling this fleet was doing far more than just keeping the vehicles driving straight. It made hundreds of small decisions every minute. When something blocked the path ahead, the nearest machine stopped and found a way around. When the asphalt temperature began dropping, the system slowed the paving speed to keep the material at the right thickness. If one vehicle drifted out of position relative to the others, the computers fixed it instantly. The result was a crew of machines that worked like a seasoned human team, except they never got tired, never took breaks, and never made mistakes from being worn out. Here is what surprised even the engineers who designed the system. The finished road was not just as good as one built by humans, it was measurably better. The surface was smoother, the asphalt depth was more consistent, the entire highway was more uniform than what manual crews typically produce. The machines did not just match human quality, they raised the standard entirely. But highways are only half the story of how China is transforming transportation. The country also runs the largest high-speed rail network on the planet, with over 48,000 kilometers of track linking cities that once required a full day of driving into journeys under an hour by train. 2 decades ago, almost none of this existed. Building that network at that speed required its own specialized machine, and that machine is called the CPG 500. Older track-laying systems work in a stop-and-go pattern. They put down a section of rail, halt, reposition, place the next piece, and halt again. The CPG 500 throws that process out entirely. It lays rails and sets the concrete blocks underneath them at the same time, rolling forward continuously without ever pausing between placements. Think of it as a rolling factory that produces finished railway track behind it as it moves. In a single shift, this machine can install up to 2 kilometers of completed, ready-to-use track. It handles individual rail sections up to 500 meters long, which older equipment simply could not manage, and it does so with a margin of error of just 10 millimeters over the entire run. The CPG 500 has also been exported well beyond China. It has laid track in Malaysia, Indonesia, and Serbia. It even built the first railway line to completely circle the Taklamakan Desert in Xinjiang, one of the harshest and most remote places on the planet, where building anything at all is a serious challenge. It may not look as dramatic as some of the other machines on this list, but in terms of how many people it affects every single day, the CPG 500 might be the most important one of all. Building across land is impressive, but building across the open ocean introduces challenges that would defeat almost any other machine. The crane that moves the ocean. Picture a vessel the length of 3 football fields placed end to end. That is roughly 300 meters of ship, carrying a crew of 380 people, floating on the open ocean. Now imagine that this same ship can lift the weight of more than 8,000 cars in a single hoist. It does not tip, it does not shake. It holds its load with the kind of steadiness you would expect from a surgeon's hand, not a construction crane. This is the Zhen Hua 30, built by a Chinese company called ZPMC, and it is the most powerful floating crane anywhere on the planet. When you see the Zhen Hua 30 from a distance on open water, it does not look like a piece of construction equipment. It looks more like a floating industrial complex that happens to have a crane bolted to the top. The sheer scale of it is hard to process until you see it next to a normal ship, at which point the normal ship starts looking very small. The reason China needed something this massive becomes clear when you look at the Hong Kong-Zhuhai-Macau Bridge. This is the longest sea crossing structure ever built, stretching over 55 kilometers across open water. Part of this bridge does not stay above the surface. It drops down into a tunnel that sits directly on the ocean floor. The tunnel had to be long enough for vehicles to drive through, strong enough to hold back the water pressure above it, and sealed so tightly that no ocean water could ever leak inside. Building that underwater tunnel required lifting enormous concrete sections, carrying them far out to sea, and placing them on the seabed with a gap between each section smaller than the width of a human finger. If the placement was off by even a tiny amount, water would flood the entire tunnel and the whole project would fail. Each tunnel section weighed tens of thousands of tons. The machine had to hold something as heavy as a small skyscraper, carry it over open water where waves never stop moving, and then lower it into the dark water until it rested perfectly on the uneven seabed below. The current pushed from every direction. The wind pulled at the cables. The ocean floor was covered in silt and debris. Lowering something that heavy into those conditions is like trying to stack concrete boxes on a table that is constantly rocking in every direction. The Zhen Hua 30 made it possible. It would grab a tunnel section, carry it to the exact coordinates, and begin lowering it. As the ocean swayed and the wind pushed, the crane's sensor system adjusted the lift in real time, keeping the concrete perfectly aligned with the section already in place below. The margin of error was not measured in centimeters. It was measured in millimeters, on the open sea, with waves rolling underneath the entire time. In 2025, the same vessel completed another milestone. It lifted an entire offshore wind farm platform and set it into position in open water, marking China's first 10,000-ton offshore steel structure installation. The Zhen Hua 30 handles whole pieces of infrastructure the way ordinary cranes handle a single steel beam. There is simply nothing else in the world that comes close. The open ocean is one kind of challenge, but reaching places where the ground itself is broken or missing requires a completely different approach. The machine with legs. Most construction equipment shares one major limitation. It needs flat, solid ground to work on. A normal excavator or bulldozer is useless on a steep hillside, in a flooded forest, on a narrow mountain trail, or in a rocky ravine. The wheels or tracks simply cannot handle it. The machine slides, tips over, or sinks into the mud. China recognized this problem and built a machine specifically for the places every other piece of equipment fails. It is called the XCMG ET120. The ET120 does not look like a normal construction machine. It looks like a giant mechanical insect. It has 4 articulated legs, and each leg can extend, compress, and pivot completely on its own. This means the machine does not roll or drive. It walks. Slopes that would send a regular excavator tumbling sideways, the ET120 climbs without any hesitation. Ground so soft and wet that it would swallow a normal machine whole, the ET120 spreads its weight across all 4 legs and keeps moving forward. People online have nicknamed it the Steel Mantis, and the moment you watch it pick its way across a mountain slope that no other equipment could reach, the name fits perfectly. But this machine is not just about looking impressive. It was built for the worst situations imaginable. Think about what happens after an earthquake, a landslide, or a wildfire. Roads are torn apart, hillsides are unstable and ready to collapse further. The ground is covered in debris, water, and broken material. Getting heavy equipment into those areas has always been one of the hardest parts of any rescue operation. Standard machines cannot reach them. The ET120 can. The arm on the ET120 accepts different attachments, so it can switch between tasks without needing a different vehicle. It can dig through rubble to clear a path. It can lift heavy concrete beams that have collapsed onto vehicles or buildings. It can cut down burning trees that are blocking escape routes. It can drill through solid rock, crush debris into smaller pieces, or even deploy firefighting equipment. Each attachment swaps in quickly, turning the machine from a digger to a lifter to a cutter in minutes. Because it is operated entirely by remote control, the human operator stays at a safe distance while the ET120 walks into the dangerous area. The operator can stand hundreds of meters away, watching the machine on a screen and guiding it with a handheld controller. This means the machine can enter collapsed buildings, burning forests, or unstable hillsides without putting any human lives at risk. China has already been using these machines in real disaster response operations. When a road washes away or a hillside gives way, the usual response is to send in helicopters or humans with hand tools. The ET120 changes that completely. It steps over boulders. It climbs over fallen trees. It plants its 4 legs into the dirt to create a stable working platform on ground that would snap the axles of a normal truck. Then it reaches out with its arm to pull heavy debris off trapped people or carve a path for rescue workers. A machine that walks through disaster zones is incredible, but some projects require going in the opposite direction entirely, straight down into the earth beneath a living city. The machine beneath your feet. Think about walking down a busy street in Beijing. There are millions of people around you. Cars are honking, buses are rumbling by, shops are open, and the entire city is alive with movement and noise. Now imagine that 150 meters directly below your feet, a machine the size of a 5-story building is slowly grinding its way through the earth. It is chewing through sand, pushing through underground water channels, and carving a tunnel through soft, shifting soil. It never stops. It works day and night. And you do not feel a single thing on the surface. That machine is called Jing Hua. It is a tunnel boring machine, over 16 meters across and 150 meters long, weighing 4,300 tons. To give you a sense of how big 16 meters is, that is wider than a 4-lane highway. The machine is longer than a full soccer field. Its job was to drill more than 7 kilometers of tunnel directly underneath the center of Beijing. This tunnel was part of a project to expand the city's East 6th Ring Road, one of the most important traffic routes in the entire city. The goal was to move traffic underground to reduce the massive jams on the surface streets above. The challenge was the ground itself. Underneath Beijing, the soil is not solid rock. It is a constantly shifting mix of sand, water channels, and soft layers that compress and move whenever something disturbs them. If the machine pushed too hard, the ground above would start sinking. If it moved too fast, the wet layers of soil would collapse inward and fill the tunnel. Any mistake, even a small one, could open up a sinkhole in the middle of a city where millions of people live, work, and drive every day. Jing Hua had to thread through all of that without a single error. Its control systems constantly measured the pressure of the ground surrounding the machine. They adjusted the speed of the rotating cutter head and the support pressure inside the tunnel in real time, responding to changes in the soil the way a doctor monitors a patient's heartbeat during surgery. Every millimeter of progress was tracked and recorded. If the machine drifted even slightly off its planned path, the computers corrected it immediately. Jing Hua did not just dig a hole. As it moved forward, it built the concrete tunnel walls behind it, leaving a finished tube in its wake. It worked without causing a single problem on the surface. No cracks appeared in the roads above. No sinkholes opened up. No buildings were damaged. The millions of people living their lives just above the operation never even knew it was happening. In its most productive month, Jing Hua pushed forward over 500 meters of tunnel. When it finally broke through to the other side, it had completed one of the most difficult urban tunneling projects ever attempted anywhere in the world. There is an extra layer to this story that makes it even more remarkable. Just 20 years ago, China did not build these machines at all. They imported them from companies in Germany, Japan, and France, paying extremely high prices and relying completely on foreign technology. Today, Chinese-built tunnel boring machines account for nearly 70% of the entire global market. They went from being a buyer to being the world leader in less time than it takes a child to grow up. Digging horizontally under a city is a remarkable feat, but before anything can rise into the sky, something has to reach deep into the ground first. The hole that holds everything up. Every tall building, every long bridge, and every offshore wind platform shares something in common. Before any of them can be built above ground, a hole has to be drilled deep into the earth. That hole has to be wide enough and strong enough to anchor the entire structure above it. If the foundation is wrong, nothing built on top of it is safe. For the biggest construction projects on the planet, that job falls to the XCMG rotary drilling rig, the most powerful foundation drill in the world. This machine is enormous. It stands 42 meters tall, which is about the height of a 14-story building. It weighs 520 tons. The drill itself can carve a hole 7.5 meters wide, which is big enough to park several cars side by side inside it. The hole can go 190 meters deep into the ground. To picture that depth, take a 60-story skyscraper, flip it upside down, and push it straight into the dirt. That is how far down this machine reaches. The XCMG rig has been used to create the foundations for some of the tallest towers in Asia. These towers sway in high winds, and their foundations have to hold them rock steady against forces that would topple a weaker structure. It drills the support piles for bridges that cross open water, where ocean currents push against the structure every second of every day. It also creates the anchor bases for offshore wind farms that must survive decades of ocean storms without shifting a single centimeter. Work that used to take weeks with older drilling equipment, this machine finishes in days, and it does so without sacrificing any of the precision these massive projects require. The rig relies on a computer-controlled system that reads the resistance of the ground in real time. As the drill pushes down, the computer adjusts the force to match whatever it is cutting through. Soft clay, dense sand, solid rock layers, the machine adapts instantly. Hit a buried boulder and it applies more force. Hit soft mud and it backs off to avoid clogging the hole. The operator sits in an enclosed cab, watching a digital screen that shows exactly what is happening at the drill tip 190 meters below. This rig has been exported to more than 80 countries. The foundations of some of the most ambitious construction projects happening right now across Asia, the Middle East, and Africa were all drilled by this machine. A skyscraper might look like it is floating in the air, but its real strength comes from the deep holes this rig leaves in the ground. Precision drilling keeps structures standing, but sometimes the job is not about being careful at all. Sometimes it is simply about moving earth at a scale that defies understanding. The shovel and the chain. You have probably seen a standard excavator working on a road project near your home. That machine weighs around 20 tons. It can scoop up a cubic meter or two of dirt at a time. It is useful, but it takes months to do what the WK-75 can accomplish before its operators have even eaten lunch. The WK-75 is one of the largest electric mining shovels ever constructed. It stands nearly 24 meters tall, the same height as a 7-story building. It weighs 2,000 tons. The tracks it rides on are taller than a fully grown adult standing upright. Everything about this machine is scaled up so far that the longer you look at it, the less your brain is able to process the size. It simply does not look real. The bucket at the end of its giant arm holds 75 cubic meters of material in a single bite. That is roughly the same volume as 2 full-sized shipping containers scooped up and dumped in one movement. Every hour, this machine processes around 12,000 tons of rock and earth. In a single month of non-stop operation at a coal mine, it pulls 5 million tons of material out of the ground. It runs entirely on electricity and produces the equivalent output of 50 car engines running at full power at the same time. That power drives 2 separate motors, one for the digging arm and one for rotating the upper body, letting it dig, swing, and dump in one continuous motion that looks almost graceful for something so enormous. Moving mountains of loose material is one job, but cutting through solid rock is something else entirely. Underground right now, there are gas pipelines keeping homes warm, power cables keeping hospitals running, and irrigation channels moving water to farms that feed millions of people. All of those had to be trenched into the earth. Most of the time, standard trenching equipment handles the job fine. Clay, sand, and loose soil are easy to cut through, but sometimes the ground is solid granite or dense volcanic rock. Conventional equipment hits that kind of material and simply stops. That is where the Tesmec M5 comes in. The Tesmec M5 weighs 77 tons and looks at first glance like a very large tractor, but attached to it is a cutting chain several meters wide. It is the kind of chain you might picture on a chainsaw, except scaled up so much that each individual cutting link is about the size of a brick. That chain wraps around a large boom that the machine lowers into the ground and drags forward, grinding through rock with slow, relentless force. It operates at 440 horsepower, and its chain spins much more slowly than you would expect. But speed is not the point. The point is torque, the twisting force applied at each cutting tooth. Granite formations that would shatter normal cutting equipment and send repair crews scrambling, the Tesmec M5 grinds through without even slowing down. A GPS guidance system keeps the machine cutting at exactly the right depth and direction at all times, adjusting automatically as the terrain changes. From a distance, it barely seems to move, but it never stops, and it never gives up, leaving behind a clean, straight trench wherever it goes. These 8 machines are not ideas waiting to be tested. They are already working in the real world, building, drilling, paving, and lifting across some of the most challenging environments on the planet. The self-driving road paver, the floating crane that sets tunnels on the ocean floor, the walking rescue machine, and every other machine on this list are already out there right now, running and producing results. If this video showed you something you had never heard of before, please hit like and subscribe. It takes just 2 seconds and it genuinely helps the channel. Turn on notifications so you do not miss the next video. Here is a question to leave you with. If one of these 8 machines showed up in your country tomorrow, which one do you think would change daily life the most? Drop your answer in the comments below.